we stop from no fine, last time we did example 18, this part, right? Sorry, odd number of observations, now even number of observations. So in this odd number of observations, like 10, here we have 30, then maybe 50, something like that, 28. So we have our median, which is Q2 here. When we are going to calculate Q1 and Q2, we have to include this mean as well in odd number of observations. Okay, but even number of observations, let's do this one. I need to sort this one. I think start from 4, 4, 5, 5, 6, 8, 6, 8, 9, 10, 13, sorry, 12, 13, 18. Do we have 10? Yes, I have 10 numbers. So now how do we find the Q2, which is n plus 1 divided by 2, that position? Since we have 10 observations here, it's going to be 5.5 position, right? So 3, 4, 5, somewhere here. Okay, to find the Q2 or the median, what you should do? At the numbers in the 5th position and the 6th position, divide by 2, right? So this is going to be 8.5. Oh, sorry, 8.5. Clear? Now, since every time this even number cases, you will be having a number something like that, something like this. That particular Q2 number is not in your observation, okay, because of this even numbers. So at that point, definitely it doesn't matter. You can simply get values left hand side to this median and right hand side to this median as your lower half and upper half. Okay, consider them separately. Do your calculations to find the Q2, Q1, and Q3. Clear? So this case, it doesn't appear in this even number of observations. Okay, so same here, you can simply find the Q1 and Q2. Sorry, Q3, Q1 and Q3. Okay, so treat them as separate set, lower half set and upper half set, and find the median. Okay, since these are all of them Q1, this is Q1, Q1, Q2, Q3, all of them are medians. Okay, do you remember the property of a median? It is it is a resistant measure. Do you remember that? It resists to outliers, median, right? Because of we are taking positions, right? But mean, do you remember, it's not a resistant measure, mean, but median is a resistant measure. So since we are dealing with medians, Q1, Q2, Q3, all three of them are medians. Okay, somehow they are medians. So this quartiles, okay, some sort of resistant measures as well. Okay, because they are medians. We will talk about them later. Now, simply we are trying to find a range in between Q3 and Q1. We call that interquartile range. Okay, so interquartile range measures the range between Q3 and Q1, quartile 3 and quartile 1. Okay, so Q3 minus Q1 gives you the interquartile range. So as I mentioned before, just before, interquartile range, okay, it measures the difference between Q3 and Q1. This automatically become a resistant measure. Okay, because it also measures the difference between Q3 and Q1, which means difference between resistant measures. So this interquartile range also a resistant measure, okay, which resists to outliers. Clear? Okay. Resistance measure. Okay. This happens because of this guy, median. Median is a resistance measure. So this happens. If in any case, you know my data set or my observations, we have outliers, then you can use median as a central measure of tendency. Measure the center, and you can use this quartiles or interquartile range to measure the variation in your data set. Okay, because these are resistance measures. We call this interquartile range or IQR, interquartile range. Okay. So now you know what are the 5 numbers in this 5 number summary. Mean, Q1, Q2, Q3, and maximum. Okay, those are the 5 numbers. So in any case, in your question, you see find the 5 numbers or find the 5 number summary or find the 5 number summary of this data set, which means you have to find all these 5, mean, max, Q1, Q2, Q3. Okay, now, if you remember when we were talking about outliers little bit in few days, few class days ago, I told you we have a proper method to identify outliers. Okay, if it is an outlier, then we can identify them using a statistical way or mathematical way. So now we are going to learn what is that method. Okay, first, outliers. As I mentioned, observations that are not, they are not supposed to be in your data set, we call outliers. They seems to be like actually they seems to be like outsiders. Okay, there are 2 ways that we can identify, or 2 ways that these outliers appear in your data set. Okay, they are very similar, but 2 ways. First case is like this. When you are taking measurements, okay, accidentally you put wrong number. Like you have to write 50, but instead 50 you write 60 or 600, 500, something like that. So this kind of thing we call recording errors. Okay, this happens. This can be happen. Yes, recording errors. Some errors, we don't know whether they are recording or what kind of errors, but they are like once you see that, you will figure it out. Okay, this should not be here. This shouldn't belong to this data set. Something like this. Let's say I'll consider 2 examples. Okay, first one, let me consider weights. Okay, weight of the students in this class, something like that. Weights. I need to fix this problem first. Okay, so weights can be like 175 pounds, 180.1, something like that, right? But if you see, once you record the heights, weights, these measurements, accidentally you get something like this. You record something like this, 0.1, which means 1800.1, right? Since these are pounds and I'm considering the weights in the students, so weights of the students, it is, you can see definitely it's an error. Okay, because of recording error, I wrote it wrong. And next one, let's consider blood types. You know, we have blood types A, B, AB, O. Oh, in this data set, you can see again A, B, O, something like that. but you will see something like this, Z. There is no blood type called Z, right? Because we don't know that kind of blood type. So once you go through this data set, you can figure it out. Okay, this should not belong here. It's definitely outsider. So in this case, simply you can remove this guy from your observations, because it's like it's definitely no, right? You can definitely identify. So you can simply remove that. But case like that, the previous example, this one, sometimes you cannot easily remove that observation, because these are some kind of numbers and they are very close to each other. So case like this one, easily you can remove that guy. But case like this, we should have a proper method to identify them and remove them. Okay. So now we are going to talk about what is that method. It is easy. This is the method. You need to know quartile range, interquartile range, which means Q1, Q2, Q3, that is stuff. That's it. That's all you need to identify outliers. Okay, this is how we identify the outliers. First, you need to calculate something we call lower limit and upper limit, which means boundary values. Okay, whatever inside this boundary, we accept them, but whatever outside this boundary, we simply reject them or consider as outliers. Okay, so these are the boundary values. This definitely gives you the value. So whatever within these boundaries or within this interval, we accept them. Okay. This we call lower limit and upper limit, or lower bound and upper bound. It is something like this. So this is your data set. I mean, you have numbers like 20, 25, up to a number 85. Okay. Once you calculate Q1, Q2, Q3, you can calculate its lower limit and upper limit, because you know IQR mean what? IQR mean Q3 minus Q1. Okay. So in this case, you can find Q1, Q2, median, Q2. Then you can calculate, okay, Q1, then Q3. Okay, these are just rough measurements. So Q1, Q2, Q3. Now you can calculate lower limit. Let's say LL, lower limit. This value is going to be like this. LL, lower limit. Upper limit can be like this. UL, upper limit. As you can see, this lower limit definitely less than Q1. See, because it is Q1 minus something. So definitely lower limit less than Q1. Remember that, okay? So this guy less than Q1. And also lower limit greater than Q3, because Q3 plus something. So this one greater than Q3. Okay, unless your IQR is 0. Okay. You don't have to show your upper limit and lower limit like this kind of square bracket. No, this is just a interpretation. Okay. Okay. So remember this one. Lower limit is Q1 minus 1.5 times this multiplication IQR. Upper limit Q3 plus 1.5 times IQR. Okay. Why this 1.5? It is something like defined like that. Okay. We have another, in this course we don't have, but in general we use 3 instead of 1.5. Like you can see when we increase the 1.5, that number, like to 3, so this interval, it becomes more wider, right? So we call it extreme measure of extreme outliers, something like that. But keep that in your mind. You need this one, 1.5 always. Okay, this is the minimum in length we can consider for this lower bound and upper bound, this interval. Okay, we will see example. Yeah, example and how we represent this kind of stuff using this. To plot or to interpret this story, the whole thing, okay, we use box plot. This graph allows us to allows us to show or represent Q1, Q2, Q3, and also outliers. That's the important part. Okay, first, to draw this box plots, you should find, first of all, you should find Q1, Q2, Q3. Okay, Q1, Q2, Q3. Then find lower limit and upper limit. Okay, those are the steps. Okay, I'm explaining these steps one by one. Third step is to identify if you have any outliers using lower limit and upper limit. Okay, whatever value less than your lower limit is an outlier. Whatever value greater than your upper limit is an outlier. It can be one or many. Okay, which means simply, let me draw here. This is your upper limit, UL. This is your lower limit, LL. Okay, so whatever value, this axis represents the value. Okay. Whatever value here, let's say here we have values, here we have values. These are outliers. These are outliers. We denote them using a star mark. See, star mark. This star mark represents one observation. So if you have three observations, three outliers, you should keep mention them three stars. Okay, on top of their values. Okay, on top of the correct values. Clear? That's how we identify. That's how we represent the outliers. Whatever outside this boundary or outside this interval, we consider they are outliers. That's how we track the outliers. Whatever inside, yes, they should keep inside as it is. Okay. Then there is something you need to know how to represent Q1, Q2, Q3, and minimum, maximum. Those 5 things. Those 5 things plus outliers, which means you are going to represent 6 things within this box plot. Okay, 6 things, 5 numbers plus outliers. You don't need to mention the lower bound and upper bound. Okay, 5 things plus 5 number summary plus outliers if you have any. Okay, using asterisk marks, star marks. This is how we you can see this down below here. This is how we draw a box plot. Why we call this box plot? Because we box these Q1, Q2, and Q3 values. That's why we call this box plot. We box those 3 values into one single box. Okay, first you have your axis. This axis represents your values, your observations. Okay. Then on top of this axis, you can mention your findings, which means Q1, Q2, and Q3. Q1, Q2, and Q3. Like this. See, like vertical lines. They are not very huge lines, some small lines. Okay, so keep these lines equal length. Then simply we connect these three lines like this, Q1, Q2, Q3. Simply we connect them to draw a box. Here it is Q1, Q2, Q3. Okay, on top of your axis. Okay. So Q1 represent its actual value here. Q2 the same, 3 same. Okay, you cannot draw this box anywhere on the axis. Okay, those values should represent Q1, Q2, Q3. Okay, then these tails, right side and left side, these tails represent the distribution, other distributed values, and the end, this end, this ends represents the minimum value and maximum value. This last two ends represent the minimum and maximum. Here this side, this one maximum, here this one, it is minimum, not the boundaries, minimum and maximum, min max. So those are the 5 numbers, min max, Q1, Q2, Q3. Okay, and also if we have any, the sixth object, if we have any outliers, definitely you should mention it here. Okay, I don't know whether we have here they have mentioned in this data set. According to this data, we have an outlier. Okay, why this guy become outlier? Because it is, if once you calculate, you will see it is greater than upper limit, this value. Okay, greater than upper limit. Sometimes you may have outliers like lower than lower limit, lower than lower limit. It's also an outlier. Okay, whatever you draw just above the line. Okay, not on the line, above the line. Don't mix them up. Yes.
So your maxes and mins are just like the maximum value and the minimum value within your upper and lower bounds. So that's why you can have something like a
yes, yes, definitely should. Give me a second, I'll explain it. Okay. So this is min, as I mentioned, this is max. Okay, but this min and max is some may or may not. Okay, may or may not same as the minimum value in your data set and maximum value in your data set. May or may not. Okay, if you have an outlier or more outliers, definitely this min and max does not match with min and max in your data set. Okay, I'll show you why. Once you calculate these Q1, Q2, Q3, then you calculate lower bound and upper bound, right? Then you figure it out. Okay, according to this case, we have an outlier. Okay, if we have an outlier, let's say this one, this outlier greater than upper bound or upper limit. Okay, so that you can consider maximum or minimum, whatever exists within your upper limit and lower limit. You have to consider everything inside that lower limit and upper limit, okay, so definitely maximum and minimum should lie inside these boundary values. Okay, clear? Since you can see this in here, maximum is 66, but according to this picture, once you calculate, you will see this one is the 66. Okay, so you have to adjust your maximum according to this boundary value. So yes, no, upper limit is not the maximum value, because if it is a maximum or minimum, that should in this data set, they should give that value either 25 or 38 or something. You cannot define any other values except these values. Okay, minimum or maximum, definitely from these values. Here you have 20, so definitely let's sort out this. You have maximum values like 66. What's the next one? 40 something, right? 43. 43, then you have 66. Okay. Once we cut off 66, because it is an outlier, so that boundary is something like this: 43, boundary 66. So whatever inside the boundary, which means you have to pick your new maximum is 43. Whatever inside the lower upper limit. Same thing this side, lower limit side. Okay. If you have outlier here, then you have to consider what the first value very close to, I mean, just after your lower bound. Just after your lower bound. From this side, just before the upper bound. Okay. So your min and max inside this interval, lower limit and upper limit. Clear? So you have to adjust your values. That's why I told you they may or may not exactly same as your min and max in this data set. Okay. I think I can show it to you using next slide example. Okay, try to, no, I don't have this else. Okay, let's do this later. Yeah, we have time. I'll explain it using an example, not this one, next one. Just before that, consider these two box plots or these two data sets. Once we draw the box, draw a box plot, we can see the variation of that data set. As you can see here, for the first one, which means table is I think runners or something like that. First one, second one. Okay, first one, second. The first table you can see that box is something like this much, but the second one box is something like this much. So box become larger, which means data variation of the data set become more and more larger. Okay, clear? By considering these gaps, gap between Q1 and Q2, you know, first one Q1, or this is mean, this is max, this is Q1, Q2, Q3. Okay, gaps between Q1, Q2 and Q2, Q3, we can roughly approximate the shape of this distribution, as well as min and max. Okay, so let's say, no, let me draw a new one. If I have a box or a box plot like this, it doesn't matter whatever inside, what is inside. It should like this. This is your mean here. This is your max here. Now you can see the length between these two tails. Length between min and Q1 and the length between max and Q3. I'm talking about these lengths. This one and this one, right? You can see, let's say this is L1, this is L2. Okay, so you can see L2 is greater than L1, which means this distribution is something like tail in your L2 side. Tail in your L2 side, something like this. Skewed one, skewed distribution, right? Skewed distribution. Skewed distribution. This is since it is in your right hand side, it is going to be a right skewed. Okay, right is skewed. This is the exact story what I was talking about. If we have symmetric box plot, which means gap between minimum and Q1, maximum and Q3, they are equal, and also the box, it's like symmetric, then definitely that distribution is symmetric distribution, symmetric one. As I mentioned, like this, see this one, this tail, length of this tail is greater than the other tail, so it's going to be a skewed one. It's going to be a skewed one. I'm not talking about Q1, Q2, Q3, that gaps. I'm talking about the tails, talking about the length of those tails. Okay. If tail is this one, this tail, it's higher than the length of this one is greater than the length of this much, it is left skew. Okay, because the tail, something like this, see this much. So it is left skew. Clear? So this is something like something you don't need to do the calculation, but just checking this box plot, you should be able to say, okay, this is a symmetric one or skewed one, skewed distribution. Okay. Questions? So anything after this moment, everything's fine. Okay. Don't think about these gaps inside the box. We'll talk about them later. Okay. Now, yes, we have an example, but it's going to be a little bit pain, right? When you okay, there is another simple example in next slide. Shall we move to that one? Because this one, if you can help me, I can do this one. I mean, if you can find me Q1, Q2, Q3, then I'll do the rest of thing and do this example. What do you say? Do I need to move to next example or need to do this one? Don't be lazy, right? Do the calculations. Okay, let's, okay. Here they haven't mentioned anything, okay? But since these values are really big, it's hard to calculate. I'm going to do the next one. This one, okay? Very same, but numbers can be changed. Okay, I'll do this one because I have 11 observations. First thing is I need to sort this list or sort these observations into ascending order from the lowest one to highest one. I can see they are okay, but yes, this guy messed up, right? This should be 2.3 and 2.4 somewhere here. Okay. If I'm going to rewrite this, I'll mess everything. Okay. Clear? So this is the sorted list. Okay. Now what? First step, find the Q2 median. Okay. Here we have 11 numbers, which mean odd number of observations. So 11 plus 1, 12, divided by 2, 6. 6 position is your median. 1, 2, 3, 4, 5, 6. This is your median. Right? N plus 1 divided by 2. N is 11 given. Okay. So 12 divided by 2, 6th position, not the value, 6th position. So 1, 2, 3, 4, 5, 6 is 2.4. Right? Okay. Then what? Then what? This is odd number of observations. So now what? How we calculate Q2 and Q3? How we consider the lower half and upper half? Including this or not? Including Q2, right? Okay. It's gonna be again. It's gonna be a pain. This is your lower half. Using this, you can calculate Q1. So what is the Q1? 2.2, right? In this case, N1 again, N1 plus 2 divided by 2. N is here, N is 6. So 6 plus 1, 7 divided by 2, 3.5. 3.5. 3.5 position. Okay. That position is in between 2.2 and the next 2.2, which means 2.2. Okay, so I don't know Q1 is this 2.2 or this 2.2, doesn't matter because they are same. My Q1 is 2.2. Oh, sorry, I haven't mentioned it here. 2.4 this one. Okay, clear? Same goes to the other side, including 2.4. You have to calculate the Q3 median of that half. Definitely, I can say it is 2.5. Q3 2.5. Okay, so most of the steps we have done. Now, second step, you have to find the upper limit and lower limit. Upper limit and lower limit. How do we find that? Lower limit equals to Q1 minus 1.5 times IQR. What is IQR? Q3 minus Q1. Okay. I'll use here lower limit. LL mean lower limit. Q1 minus 1.5 times IQR. So IQR is Q3 minus Q1, which is, sorry, let me write IQR here, which is 0.3, right? 2.5 minus 2.3, 0.3. Now, Q1 is 2.2 minus 1.5 times, I'll use brackets to show the multiplication, IQR 0.3. So what's this value? This becomes 0.45, 1.75. Yeah, it is 1.75, right? Right. Then upper limit, Q3 plus, definitely plus, not minus, 1.5 times IQR. Again, IQR, the same value. It doesn't change. Q3 is what? 2.5 plus 1.5 times 0.3. 0.3. Sorry, this is not 15, this is 1.5. Okay. So, so 1 point, again, it is 0.45. You have to add to 2.5. So it is 459, 2.95. Okay. 2.95. So now you have figured it out what are the lower limit and upper limit. Clear? Don't draw these brackets, what I'm going to draw here. This is your Q2, this is your Q1, this is your Q3. Okay, I'm not going to write the values, you know the values. So now what? You have your box like this. Okay, tell me the gap between Q1 and Q2 is greater than or less than the gap between Q2 and Q3. Q1 and Q2 is greater than the other one, which means it's going to be like this. So your Q2 is something like this, because this is here 2.2, this one is 2.4, gap between those two 0.2. Q3 is 2.5, so gap between 2.4 and 2.5 it is 0.1. So can you imagine what I'm talking about? Something like this. Okay, so try to keep these gaps, but I don't expect from you. Okay, but in general, yes. Now, what are the lower limit and upper limit values? Lower limit 1.75. Don't draw this bracket. Okay, it's not necessary. This one 2.95. Okay, now I'm going to definitely my min and max inside this boundary. Okay, very close to boundary or whatever, definitely inside the boundary. Now I need to find the min and max. Okay, to find that I need to find before I need to find, do I have, I mean, before I find, I need to find outliers. If I have any outliers, then you have to show them here. Let me check. First, I'm going to check with lower limit, this 1.75. If it is outlier, if any observation or any value less than 1.75? No, right? No, because value will start from 1.8. So which means there are no values this side. So your minimum is as it is 1.8. Okay, that's your minimum. Now go to the maximum. Do we have any value or values greater than upper bound or upper limit 2.95? Yes, 3.6 is there, right? 3.6 greater than this value, which means let me 3.6. So this becomes an outlier. 3.6 become an outlier. I mentioned them using asterisk mark. Okay. Now, what is the maximum? Inside the boundary, what is the maximum value that I can bound within using this upper limit? 2.6. Okay, so your maximum is 2.6. Clear? Okay, that's how we find the minimum, maximum, minimum and maximum. But don't use minimum and maximum, what you can see in the data set. Okay, after removing these outliers, you can see the actual minimum and maximum. To calculate the interquartile range or Q1, Q2, Q3, we use outliers as well. See the difference? Okay. For these calculations, we use outliers. But once we figure it out, it's an outlier, we remove it like this. You cannot simply throw this guy out. You have to mention, okay, this is an outlier. Okay. So don't confuse. If this is an outlier, why we used to use that guy to calculate Q1, Q2, Q3 or interquartile range? Don't think about that. Okay, we use that because otherwise we cannot find this one. Okay, clear?